Okay, good morning, everyone, and welcome back to this is the first day of the fourth iteration of our data analysis apprenticeship training. So welcome, and I wanted to very quickly let Mr. Lonnie Emmerd, my supervisor and our director of apprenticeship, welcome everybody to the program.
Well, thanks, Don. And I do look forward to having everybody who I've become aware of one way or another through either email, or I've met a few of you and certainly spoken at times to welcome you. But for this particular opening day of your training, I guess the comment I always like to make as we start these is that, it's a little different than most educational efforts that you've probably been involved in, because you're here as an employee, as an apprentice, and that you're that first, right? And a student second. But at the same time, Don knows that as you want to build your skill set around data analytics and being the best, at what your craft is, this apprenticeship program is designed for you to learn and apply very quickly, right? The idea is that this is a magical secret sauce to apprenticeship that says, I have skill building, classroom, kind of things that I need to learn in an educational model, but yet at the same time, you're going to go back this afternoon and other days when you're not in class, and you got real work to be done. And hopefully the goal here, and we've proven it time and time again, is that you'll make the most of this experience if you ask questions, learn from one another. Don's got a wealth of experience to bring to bear, along with some other experienced folks that'll come to you over the course of these next few weeks. And I just want to let you know that ACDS is really defined by the fact that you've made this match already, that you've come to enter into this opportunity with your company, and they see it as valuable. And I hope you see it as not just valuable right now, but for the rest of your career, because when you finish this apprenticeship, you'll have a credential that goes with you no matter where you are. And it'll represent the fact that you achieve something significant. And so my encouragement to you as you start this is that you lean on us when you need to. You turn to your mentors at your company, the leaders there. They all know that this is a collaborative effort for you to be successful. And in the end, everything you're learning, it's up to you to deliver on that, right? I mean, in the end, you're the one with the work objectives that you'll be able to gradually take on more and more responsibility because you've learned and you've applied. So, Don, with that, I just want to, maybe have everybody get a chance to introduce themselves, and that's my kind of introductory comments. Short, sweet, but very direct as to just wanting you to know that we're here for the ultimate support of your success. Thanks, Don.
Sure. Lonnie, would you like to hang back or stick around while everybody introduces themselves?
Yeah, that'd be great.
Okay. Let me move to that slide. Okay, I'll just to make it easy, I'll just go in what I see as being order on my screen. Dexter, why don't you go ahead, and there's just some prompts there. You're welcome to craft your own introduction.
Yes, sir. Good morning, everyone. My name is Dexter Brady. I'm from Dallas, Texas. Been here in Pine Bluff for since 2013, graduated from UAPB. Right now I'm working with Simmons apprenticeship through People Shores. It's nice to meet y'all today.
Nice to meet. What'd you study at Pine Bluff?
Computer science.
Awesome. Okay, nice to meet you, Dexter. Well, we've met before. Good to see you again.
Yes, sir.
Okay, I don't believe I've ever met the next person I see on the screen, Seth.
Sorry, I'm having a little trouble with my microphone. Can you guys hear me?
Oh, sure can.
Okay. So yeah, my name is Seth Turbyhill. I was born in Arkansas, but I've lived in about 5 or 6 different states before I came back. to Arkansas pretty recently, I think a year ago. Currently, I'm working at Bumper to Bumper Auto Parts. I'm helping them handle some of their quarterly and yearly promotions, basically tracking and fulfillment on those, using mostly like their SQL databases like PostgreSQL and things like that. I've got an associate's degree in mathematics from the Oklahoma City Community College. And I guess that's about it.
Okay, well, welcome back home, Seth. This place has its own gravity. I know a lot of guys in the military that were stationed here and never left. A lot of them, more than any other place I've ever been stationed. Arkansas feels like home. So nice to meet you. Looking forward to working with you. By the way, my son is a SQL developer, a data engineer upstairs from you at Bumper to Bumper. He does a lot of the queries and SSIS packages that are populating that Postgres database. He's also an apprentice with ACDS. So joining the family business. Next on my screen, Edgar. Do you go by Edgar or Ed or?
Just Edgar.
Edgar. All right. Nice to
Yeah,
meet
it
you.
doesn't really, I don't really mind. So my name is Edgar. I went to the University of Arkansas and got a degree in MIS. I'm currently working for Shiloh Technologies as an IT analyst. That involves a lot of data analysis, SQL work, Excel, running reports. Hobbies, I play pickleball every other day, I like rowing, I like Formula One.
Did you say you play pickleball?
Yeah,
Pickleball. I've heard of it. Never played it.
little like tennis, but easier.
Edgar, I've picked up pickleball over
Yeah.
where my wife and I are part of a club here, and so when I come to Northwest Arkansas, if you're playing every other day, I'll
Yeah.
connect with you, and we'll have to go play.
Yeah, I go to Lake Bentonville to play. There's like 4 courts there for free.
Yeah.
Yeah. And I think that's it. Nice to meet you all.
Okay. Nice meeting you, Edgar. And Kevin?
Hello, yes, I am Kevin. Nickname Kevin, I guess. My hobbies, I like to go to the gym. I like to play video games. Recently, I've picked up trying to learn other languages as a hobby. I mean, I did in college, I took Spanish, also majored in biochemistry. Currently, I'm working with Harbor Environmental as a systems developer. And that's kind of like an in-between of like internal programming and also data analytics. And I started just this year, actually. So I'm excited to take this course.
Nice to meet you, Kevin. Do you work anywhere near Don Tribble?
Yes, we are in the same department. We have like a 4-person cubicle, and he's just across from me or next to me.
Okay. And then I want to say Lauren Stout.
Lauren is down the hall from me. Yep.
Yeah, Teresa has had several apprentices, and so so welcome. And last but not least, Christopher, you have not gone yet, have you? Other than saying good morning.
Good morning, everybody. Nickname is just Chris. Hobbies are pretty basic, fishing and watching a lot of Star Wars. Where I work at Southern Bank Corp. I've been here for almost a year now, originally from the Mississippi Delta, Greenwood, Mississippi. My duties here at the bank, I'm actually kind of one of the first data analysts here. We're working to kind of build out our data analytics team and just looking ahead at, so add those necessary skills to be able to lead that team and just tackle the organization's data problems and try to make our processes more efficient. As far as my work history, I've been in banking for about 10 years in various different departments, including operations, compliance, the retail bank. I've done a little bit of everything, but data is kind of that new challenge, and just looking to embrace it and really learn. I can learn all I can learn from you guys and Don as well. Nice to meet everybody.
Nice meeting you, Chris.
Don, this is a good group. So I know you still got Cameron and maybe a couple more yet to be added, but I'll jump off and you guys can get after it. But I'm really excited to get to know each and every one of you a little bit better. And like I said earlier, why we care about you and we want you to have the best experience you possibly can. And you've already talked to some of our project management team, probably Kelsey or Jarrett, who's come on board. And so anyway, Don, you know that that you can always tell them they've got all the support from our team, especially through you. So anything else that you got, Don, or you want me to? I'll be ready to jump off.
Nothing real quick. Thanks for joining us, Lonnie. Appreciate it. And we'll talk to you soon.
Okay. Good luck, everybody. Appreciate you. All right. Bye-bye.
Okay, we'll see you. Okay, well, nice to meet all of you. Sounds like everybody's got an IT background. So just real quick about myself. I'm retired Air Force officer. I did 12 years enlisted and 18 after officer training school, 18 commissioned. Started out as an electronics technician working on, like I was telling Lonnie about these C-130s. I did my first assignment here in Little Rock, moved to Arkansas in 83, met my wife, met and married her in 1984, and we moved away. But we always knew we'd come back. Arkansas has always been, I was raised as somewhat of a military brat, gypsy, so we moved around a lot. So Arkansas has always been basically more home than anywhere. I go by Don. I've got a doctorate in computer science. I finished 3 years ago, master's in telecom. When the internet happened back in the mid 90s, everybody in the military ran away from software and towards networking because they kind of realized that we wouldn't be writing software in the field, but we could very well jump out of the back of a cargo jet and set up a tactical network with, satellite dish and microwave links and Cat5 cables strewn across the desert to all the tents and everything. And that's so, yeah, I got into networking somewhat. But I'm a programmer at heart. My first 6 years were in database development. I developed Oracle applications mostly, but I did some general purpose programming. I guess my my biggest claim to fame, my 15 minutes of fame, I designed and developed with a couple of other guys that were a little junior to me, the first application in an Air Force recruiter's office where when they're typing in all your information so they can do your background check and get you your health information and all of that. There's like 26 paper forms that they would fill out, and they were doing it literally. This is in 1990, 90 to 93. They were doing it on carbon forms, and then sending them off to various agencies. And one of them was like a 5-copy carbon form. So anyway, they're doing it on typewriters, and all that old school stuff where if you get something wrong, you got to start over again because it's kind of hard to do corrections on carbon paper. And then you don't really have it as data. The forms have to be literally mailed somewhere. I mean, it was just ancient 20th century technology. So I put together an Oracle database that just that collected all of that information on data entry screens without really worrying about what the form would look like. And then we actually wrote the C code to print the forms mimicking what they looked like on a dot matrix printer. And then, it networked the computer so that the data could be moved around electronically. But that got fielded nationwide on every recruiter's desk. And I was in San Antonio at the headquarters at the time. And I went on vacation to Atlanta where my folks lived, and my brothers were visiting there. And we went to the Olin Mills and got a picture taken, portrait. And there was an Air Force recruiter right next to the Olin Mills. And I said, "Hey guys," and I saw the guy sitting at his desk. I said, "Hey, come here, let me show you what I do for a living." And I went in there and was showing the recruiter some undocumented features and everything. And I got to show my brothers in Atlanta, Georgia, what I did for a living, in San Antonio. Now today, y'all, that's not cosmic whatsoever. If you're a web developer or a mobile app developer or anything like that, you can do that sort of thing. But that was, 32 years ago, 30 years ago. That was the one application I did that no kidding was nationwide and whatnot. And then I screwed up. I finished my MIS. I got an MIS also. Edgar, was that you that had an MIS undergrad? Or one of y'all told me you had a management information systems undergrad. Which one was that?
Oh, my bad. It's me.
That was you, Edgar. Yeah, okay, I thought so. Yeah, that was my undergrad as well. And then went to officer training school in '94. And then they don't let you stay technical. So, but they expose you to a lot of different topics. So, as an officer, I worked as a software engineer, looking at software engineering processes and the quality of the software coming out of those development efforts within the DoD large scale contract aircraft programs and things like that, space and missile programs. And then I ran a network control center for a little while. We had the firewall, proxy servers, file servers, antivirus server, the help desk, all that kind of stuff for an Air Force base in northern Japan. Then I was an analyst for a little while, for a year and a half or so, doing nothing but Excel charts and tables and embedding them in PowerPoint so that that information could be briefed up to the chain of command, pulling data from a bunch of different systems. Nothing's changed. And then some other, higher level management information systems, knowledge management, information management type jobs. So, but at heart, guys, I'm a programmer, a coder, database guy. So I love Python and SQL. Those parts of this course to me are the most near and dear. As far as teaching goes, I've been adjunct faculty for a couple of different colleges since about '05. So I've got some teaching experience, and like I said, this is the fourth time I've taught this course. I took a 7-year break after 30-year military career with a decent pension and a couple of college courses to keep me occupied. My wife and I moved into a motorhome and traveled. After a couple of years, I felt like I was playing hooky. I retired at 48 because I joined the Air Force right out of high school and did 30 with no break. So I started feeling like maybe I, needed to kind of do something to be productive. So I found an online doctorate with Colorado Technical University, and I finished that while we were on the road. So I know all about distance learning and all of that sort of stuff. And then when I came out of retirement, I worked at UCA, University of Central Arkansas in Conway. They've got a coding boot camp called the Arkansas Coding Academy, and it focuses on full stack web development, so Java, SQL, and how to expose that data from the database to Java, and then the web page pulls the data from the Java objects, Java classes. So that was interesting. But then I came to work for ACDS. I work part-time. I'm 20 hours a week with ACDS, and I've got a couple of teaching gigs. And I'm, an old retired guy. So that's me. I got 3 adult kids, 1 grandbaby, and I play guitar as much as I can. Those are all cheap guitars, by the way. It's not like I'm got any museum pieces back there, but I love picking guitar and singing a song around the campfire, that sort of thing. Okay, so that's me. I'm a mile wide and an inch deep. If I don't know something, I'll find it out. I'm a professional Googler. Okay, more about the course. Okay, so I developed this course curriculum basically by looking at everything that was available out there and just averaging everything out and deciding what was appealing. So we'll talk about everything data as far as the actual electronic formats and whatnot. We'll do several data analytics projects that are from problem identification through capturing the data, cleaning the data, analyzing, visualizing, and storytelling the result. We'll do a little bit about descriptive statistics. I'm still trying to get a guy that's confident with inferential statistics. If you haven't had stats, descriptive is what the data you have looks like, what it says, and inferential means in inferring those numbers to a larger population. Like you'll see poll results for political polls, with a plus or minus a 3% degree of error or certainty, whatever, that's inferential. So normally I'm finding I haven't had a student yet, and this is the fourth go around, so maybe 40 folks. No one's using inferential statistics at work. No one is saying, okay, we've got 100 samples of customer data. We need to extrapolate that to the 10 million customers we have with what degree of confidence and whatnot. But I still think it's good to know as an analyst. So like I said, I'm trying to get a workshop put together for that. Yeah, Excel. We'll do a 2-day. I think everybody knows Excel, so I'm going to have a daily user come in and go through rapidly, keyboard shortcuts and pivot tables and functions and those, including VLOOKUP. I even saw somebody put VLOOKUP, which is a specific function in Excel that lets you grab data out off of one sheet and match it up with data on another. They actually put that one function in Excel in their resume as part of their Excel skills. So it's interesting. It's kind of like joining tables with a where clause, as far as I'm concerned. If you know SQL but you don't use VLOOKUP, that's what it looks like to me. But anyway, and we will do a lot of SQL queries. I try and balance hands-on, a lot less talking and a lot more hands-on once we get rolling with the course. Sorry, today's just going to be me yapping. Data storytelling we'll do with dashboards in Power BI. And then my favorite part of the course personally is Python. Since everybody's, it sounds like everybody's had some coding experience, I will just, kind of give my 2 cents on software engineering and coding conventions. And we'll work through the Python syntax from hello world through wrangling data in with a library that you import called pandas. It's one of the reasons Python is so popular. Is because it's so easy to script your data engineering. So we'll we will work on a lot in Python, and then as we're able and as available, I bring in guest speakers to talk about, like GitHub. I've got a buddy that's a CI/CD engineer at Axiom, and he's a GitHub expert. And if nothing else, I've got a how-to R video that one of the professors from UCA came in and did. I frequently have a guest speaker that does some data mining and machine learning in Python. I'm trying to find if any of y'all know a NoSQL developer like MongoDB or or any of the NoSQL options that are available in the cloud, let me know. I'd love to work them into the course for just like an hour-long TED Talk. Okay. All things data analysis. Okay. Yeah, 8:30 to 12:30, try, do your best to make it. Your employers have basically agreed to this, with a little bit of exception. Dexter and Cameron might go on shift work, in which case we'll do things asynchronously. But I will often break class early when I have an exercise, and so I don't ask for anything outside of that 8:30 to 12:30. Generally speaking, although you're welcome to, it's just not fair for me to. That's the expectation set with your employers, is 4 hours twice a week, and that satisfies everyone's obligation to the course. So yeah, first weeks we'll do foundations and some Excel and Python, and then we'll do some hands-on after that. I want to say I start SQL in week 5. Around midway through the course, we'll do actual Python exploratory data analysis and storytelling using Jupyter Notebook. I got that on the next slide, though. That's the environment we'll program in Python. And then some Power BI. I reserve a week there for advanced topics and kind of prepping to go into the cumulative work. And then 15 and 16, be thinking and talking with your mentor supervisor about a project you can do for the course that it's work related. We hopefully a cumulative project that you do that that is something you would be doing anyway, that is maybe a new measure or a new set of measures, or you're using a new tool. I don't put any artificial limitations on what you can do for that project, but I will go over kind of what that looks like, or what it will need to look like, because on August 25th, you'll come online, brief that up, the results of your cumulative project, and we will be done. Yep, May 10th through August 25th, twice a week. Any questions so far? How's everybody doing? I see Kevin says he's used MongoDB, but doesn't want to teach it. Yeah. All right. Well, Edgar, if you ever decide you might want a career in the military, shoot me an email. We can certainly talk about it. I'm looking at the chat there, guys.
Might have to get a referral.
Yeah, I get a bonus if I talk somebody into it. No, I'm kidding. It was a great career. They train you well. You you absolutely lose your freedom. You don't feel like a prisoner. You feel like a airman or a soldier or a sailor, because you wake up when they tell you to wake up, cut your hair, wear the clothes, speech patterns, you live where they tell you to live. But the reward, at the end of the day, at the end of 30 years, I look back on it fondly. I guess that memory is like that, though, right? You never remember the stuff you hated at the time. You just remember the good stuff, which I guess that's healthy. Okay, so that is our schedule. And I daily, or the rhythm here in the course, if I am still talking at 15 minutes after the hour, and I haven't already said, let me just finish this real quick and we'll go on break, if it sounds like I'm just talking my way into the distance with no end in sight, and I get distracted, please let me know, because I'm adamant that we will take a 15-minute break every hour. So talking and listening, Zooming for 15 minutes, and then get the heck up, hopefully get up from your computer, walk around, exercise your eyeballs. If you have to, check your email at work, but maybe that's a chance to check your texts on your phone, those sort of things. So yeah, we will talk from half past the hour until quarter after the hour. Generally for about the first 3 hours. I can't really go longer than that. My head starts to hurt from the headset. My voice starts to hurt from talking. So, lucky for you, I do try to balance hands-on with talking. Okay. So 906. All right. So the software we will use, if you haven't seen this list, I apologize. I sent it out a couple of times to different folks and talked about it. The Canvas LMS, I saw everyone. Did we get Cameron in yet? 1, 2, 3, 4, 5. Nope, no Cameron yet. I saw everybody's accepted the invitation. So basically what the classroom looks like. I'll just pull it up real quick here in a minute and do a demo. Zoom, of course, we're on now, and by now everybody knows Zoom etiquette. Mute your mic. If you're talking occasionally, please turn your camera on, so that it's a little more like human interaction. If you do not have a camera, I guess I understand, but I think we're all kind of working remotely. Are any of you working at work?
I'm working at work.
Edgar's at Shiloh. Seth,
so am I, but I don't have a camera on my computer.
okay, but Seth, you go into bumper to bumper, right?
Yeah, I'm there now.
Yeah. Dexter, are you in Cameron and are you guys working from home, or is there a work center? Yeah, I know somebody calls you out. You gotta find the mute button. I think one thing for Zoom, I think the space bar will unmute you. How about you, Chris? You go into the office?
I am on most days, except like Fridays. I'll work remotely.
That'd be a good compromise. A hybrid where you work from home at least one day. I'll never go back to the office. I say never say never, but I have no intention of ever commuting again. I wouldn't mind like a short-term gig, like consulting or something like that. But as far as just driving across town to the office every day, I don't see it happening unless it's a really good opportunity. So yeah, Zoom, the normal rules apply. I think everybody's got that going on. Normally everybody has Microsoft Office installed. If for some reason you don't have access to Excel, please let me know. It'll be kind of tougher to do hands-on, but there's some other options. Python, but the distribution, don't just install Python, install the Anaconda distribution of Python. It's called the Anaconda individual edition. Any questions or concerns about that one? Takes a half hour or so to install after you download it. Everybody's got it already?
I have a question.
Was it Chris or Edgar?
It's Chris.
Chris, go ahead.
I have an Anaconda Navigator. Is that the same deal, or it was a little?
Yeah, Anaconda Navigator is how you maintain kind of the software environment of what packages are there. I'll do a quick demo before we end today to show you what once you install and get it on your start menu, you're good to go. So if you've downloaded an Anaconda individual version and you've got let me quit sharing what I got. I'll just go through that right now. Stop share. So share entire screen. Share screen, share, zoom. Everybody got my whole computer?
Yes.
Okay, once you download the Anaconda individual edition and install it, you'll get this Anaconda 364-bit folder on your start menu. The Anaconda Navigator is like I said, it's the software environment. There are components to Python that Anaconda Navigator helps you maintain. What we will use is this link down here that says Jupyter Notebook. You click on that and it will create a new tab in your browser, your default browser. Put the zoom away again. It's cranking. What it does, what Jupyter Notebook is, wildly popular especially in the data analysis, data science community. What it does is create a web server on your workstation, a virtual web server. So, and then it brings up a tab that is a file explorer. So it looks just like good old Windows Explorer. It's the same view that you get when you bring up Explorer, in your default view. So it should look the same folders and everything as when you pull up Windows Explorer. Good grief. How do I get rid of that now? Get away. So yeah, when you first run Jupyter Notebook, it cranks up the web server. It cranks up a version of Python that so it understands when you're writing code. And then it shows you your file structure. So I've got my Python stuff in on my OneDrive under Documents, under Python. And then I keep my each Python program that you write in this environment is called a notebook. That's what Jupyter Notebook. And each one is a self-contained file called an IPYNB. You'll see this extension, IPYNB. And each one of these IPYNB files is a Jupyter Notebook. And well, I'll just go ahead and pop one open. I'll do this in more formal fashion later in the course this week or next. But this is a Jupyter Notebook. It's a web page. That's all it is. It's a web page that has kind of like HTML markup. I double clicked on that and you can see kind of what the markdown language looks like. It's kind of sort of like HTML. But then but it's for documentation. It doesn't execute Python code, but it allows you to create a really, information rich coding environment, way more readable than just comments in your code, So yeah, this is a Jupyter Notebook and this is all documentation that you're seeing. The first code cell is this little hello world program. And that, if you run that, it's actually Python code, and it will actually execute in a code cell. So there's 3 types of cells: Markdown, code cell, and then a thing called NBC convert, or raw NBC convert. We'll only use Markdown and code. So that's really all you needed to use. When you go to your start menu and you find your Anaconda folder, run Jupyter Notebook, and you'll be ready to go. Cool.
Cool.
So yeah, I apologize. That's a long answer to a short question, but that is me. Okay. So it is 9:15. Let me see here real quick. We say, and we always, you'll hear me say this 500 times: file, close, and halt a notebook, and then we quit out of the main Explorer view. But I'll do a full demo of this probably Thursday morning. Okay, it's 9:15, guys. Any questions before we go on break? Okay, to be continued at cell phone 9:30. I use my cell phone as a universal correct time. See you back at 9:30. Okay, welcome back. Second hour. Back to death by PowerPoint. Okay, so yeah, Anaconda distribution includes tools as well as the actual Python interpreter, the engine that interprets your code and gives you your output. The next program is called MySQL Workbench. Pretty sure it's on version 8. We'll be using that to write SQL queries against a MySQL, actually MariaDB, in the cloud, in Amazon Web Services. We won't be using MySQL Workbench for a few weeks. So if you don't have that one installed, don't sweat it so much. But Excel and Python and Anaconda, we'll be using more or less right away. I don't have any assignments on either one or exercises until next week. But please let me know if you don't have those installed, and what I can do to help. MySQL Workbench, if you're using a work computer, we need to talk about if the test doesn't work, get it installed as soon as possible if you're using a work computer behind an enterprise firewall, because I've run into problems where the port, trying to remember, 3304, the port and IP address of the server you're connecting to might need to be opened up on your corporate firewall. So let me know. Did I resume recording? Yes. MySQL Workbench, and then Power BI Desktop is free out at Microsoft, and it's an application like they call it Excel on steroids. It's like Tableau, does charts and graphs and reports and dashboards, but it lets you publish sort of a web-based version of your dashboard to it's called the Power BI service. It's a web-based service. So we'll just go over the basic mechanics of using that tool, so that you've got another tool in your toolbox. So that's the software we'll use. Anything else will be just demonstration. So you won't have to worry about installing it, or it'll be web-based, and you won't need any new software. I would like to take this course 100% web-based, but I haven't done it yet because these environments are so cool, particularly at Jupyter Notebook. If you get into it, like out on Kaggle and GitHub, there's just an enormous volume of really good sample code and documentation in the format of these Jupyter Notebooks, because they're so pretty and they work so well. Okay, so like I said, I'll try and stay within the 4 hours, 2 days a week. I particularly with Excel or I'm sorry, with Python and SQL, since the getting the syntax right and getting those to work is a little more complicated than maybe Excel or even Power BI. I've got more brain teaser exercises on those than the others. But your cumulative project, you can use all, some, or none of these tools. There's a company that runs the aircrew training out at Jacksonville and several other Air Force bases. They use a tool called Domo that looks very much like, Tableau and Power BI, to include the data ingestion part of Tableau. The name of that escapes me. It's a separate tool. Anybody remember what it's? Tableau Prep. I beat you. Tableau Prep is like a separate component of Tableau that lets you automate. That sure looks like it, Edgar. By the way, I just saw your chat, Edgar. That looks like. Let me hit it. Do. Anaconda. Yeah, you want the appropriate Windows version. That looks like it. 64-bit. Yep. And you should, yeah, and you'll wind up with the same folder structure I have. Cool. All right. Back to Death by PowerPoint. So you can use whatever tool you want. The lowest common denominator, that's easiest to do is your charts and tabular data, table data, small data tables would be in Excel, and you would paste them into PowerPoint and walk through your project using PowerPoint. But you can use a Jupyter Notebook, share your screen and use the Jupyter Notebook. You can use a Power BI dashboard. It allows you to do tabs virtually identically to Excel. And you can put text boxes and stuff so it almost looks like PowerPoint as you share it and display it. So all, some, or none of these tools. So as we go through, just kind of be thinking about what you would do. It's kind of like, well, I'll do a few for examples, but it's just walking through a data analysis project from start to finish. And yeah, please start thinking about what you would do work related. It could be some side project that nobody's quite gotten around to, or somebody started and didn't quite finish, or it could be a modification or a supplement to the way you're currently doing reporting, and you're just adding new functionality. But try not to just do something that you're always doing. Don't just run the monthly report like something that you're already doing that's super well greased. Try and spread your wings a little bit on this project. A note about confidentiality. So academic freedom and non-attribution. That's kind of like the old, what happens in Vegas stays in Vegas. Somebody might say something about their company's data environment, or, something they might talk about, I don't know, some company out there that they hate or love or whatever, or express a political view, just kind of, let everything sort of stay within the class, so that we don't feel like we're being repeated outside of class. And that includes me. I may render some opinion that you might think is worth conversation, but maybe somebody else would think, well, he shouldn't be saying that. Or anyway, this hasn't come up. But just be aware, we're going to be together for hours and hours and hours over the next 4 months. Please keep in mind your organization's proprietary data or customer data, or I don't think we have anybody in healthcare. So HIPAA data for sure. So, no one will ever expect you to show real live data, customer data, or anything like that. So just, if for whatever reason you're sharing your screen and maybe I'm helping you with something, don't get any of us in trouble. Yeah, particularly PII, HIPAA, FERPA is something you only deal with in education. So yeah, just respect everyone's kind of right to professional privacy, confidentiality. Okay, so if you haven't already gathered, I'm rarely the smartest person in the room, especially in a group like this. It's kind of nerve-wracking for me because you all are working in the tools and in your functional area and all day, every day. And I'm trying to pull together a course that's broadly appealing across multiple functional areas. We've had, marketing folks, cybersecurity analysts, people in healthcare analytics, a guy at Arkansas Heart Hospital. So there's just it spans the gamut for functional areas. So it's really hard to do anything specific. So I rely on you guys. That bullet number 2, learning is a collaborative endeavor. If you're hoping to not ever say anything in this class, or if you're reluctant to contribute, I really, really hope that you'll change your mind. Because if I just yap, this whole course, it's going to suck compared to if you guys share your experience and your thoughts and your wisdom with each other. It'll make it a whole lot more informational than me just working through the classroom curriculum. So if you're shy, please get over that. And when I ask, is anybody race to be the first one to come off mute and contribute, please, or it's going to be a long 4 months. That's all I'm saying. So yeah, like that, the cohort adds as much or more value as the actual curriculum, if we do it right, if we do this right. And for me, teaching is fun because it makes me think through what we're talking about and learn it so that I can describe it accurately and succinctly. This is particularly true with these software tools. It forces me to be better at it than I might without, having a teaching gig. And if I don't know, man, I ask away. You won't embarrass me. I know a lot of stuff, but there's a whole lot more I don't know. But I love learning and I love helping solve a problem. So if I don't know, I'll figure it out. So like, for example, one of the students outside of really the class, they were at work, they were getting survey data in the form of like a CSV, and it had like the healthcare provider's name and then some columns of their satisfaction score and whatnot. And then it even had a column that had their email address on it. So, and this guy had never programmed in Python or any scripting language before at all. So I helped him write a Python program that iterated through that CSV file using the Python magic we'll learn later in the course, and send out a form email to each of those providers. And in a large hospital, we're talking dozens and dozens of providers. They had been cutting and pasting and manually emailing that line by line by line by line. There's a book called Automate the Boring Stuff for Python. And that's what we're talking about. So I helped him write that. He got it going using a work related email address. I was using Gmail. He had to convert it to Microsoft Exchange, but we got it working. And man, that was so rewarding for me because it's hands-on and I had to learn, and I had to learn how to send an email with Python. But I loved it, and it was outside of class time, and that's okay because I'm an old retired guy and I've got some spare time. So if there's anything I can do to help you outside of class, whether it's work related or just something you're pursuing, you just want to bounce an idea, please. I love contributing like that. So let me know. Let's see, one more on mechanics. Yeah, I'll share my screen here in just a minute and we'll look at Canvas. And I've got a YouTube channel, but I post the link in Canvas for every class. It usually takes me a little bit after class to get it rendered and saved and everything. Yeah, if I forget break, remind me. I like to see you guys. It makes this less of an endeavor where I feel like I'm just talking to myself, because literally I am looking out my window at a bunch of pine trees right now. And I do love interacting with fellow human beings. So if you have a camera and we're talking about something, love to see your smiling faces. And yeah, very often I'm looking at something. Like right now, I can't see if you put your hand up or did some, even if you turned on your camera and waved at me right now, I am looking purely at my PowerPoint. I have the participants minimized. So come off mute and say, Don, Don, and stop me if you have questions. Okay. There you go. There's that one. Any questions on any of that so far?
No questions.
Okay. I am looking at the screen now. I don't see anybody coming off mute. Whoop, Dexter, got a question?
No, sir. No questions.
Oh, okay. All right. Next one is let me share my whole screen. What am I looking at here? Yeah, I have to share the whole thing here. I wanted to show you Canvas real quick. You've all accepted the invitation, so I know you're all in here. So in my view, right now I've got it in student view. In my view, I've got a few more things like attendance and some editorial stuff. But when you come in here, this home is very much a mirror of this link that says modules. Each of these foundations and data analysis with Excel, relational databases and SQL, my Python module down here, and I'll have another one with Power BI. Each one of those contains, I guess you call them objects. Some of them are files. Some of them are like under Excel here. You see in this Excel data analysis project, that's something that you'll click on and upload an Excel file to. So that's what the one mechanic is uploading an assignment. But I've never had anybody have any trouble. But if you have any trouble, holler and we'll work it out. But that's some of them are pages, some of them are files, some of them are assignments or exercises. So like for instance, once you get Anaconda downloaded, you can check it. Put this, and I've numbered them because we have to go in order. Intro to Python and Notebook, you can download that and then run Anaconda like I did, and then just navigate until you find that file wherever you put it. I suggest when you start working with Python on your computer that you have a Python folder somewhere that you put all your Python stuff in. And underneath that one, have one called Notebooks. And then at the same level as Notebooks under Python, have one called Data. Because a lot of my notebooks that open a file and use external data expect there to be a folder structure where in, at the same level as your notebooks, there's a data folder. And I'll go into that when we start working with Python. I'll show you. But this is Canvas. This is the pretty much the these modules are all you really have to worry about so much. Although every file that gets stored here usually winds up here in like a library of files. But that's about it for that one. Canvas. So that's, yeah, assignments and materials. Close that out. Okay, now a little more foundational yap, and I wanted to talk about the world of data just to set the scene and find out kind of where you guys are at. And like I said, you guys are in the business, so none of this is really a surprise to you. Just want to make sure that we're all setting the stage. And there's a little bit here on roles and responsibilities I want to cover that that may or may not line up with what you're seeing at work, and I'd happy to discuss that. When I tell you how something is done in industry, it's very generic. Every business is welcome to organize and equip its workforce to its own satisfaction. So I'm just showing you what I know to be widely reported. So take that for what it's worth. Now, I guess that's another academic freedom. Like, if I say something, I'm not, professing it's the only way, or that anybody that doesn't have these roles or responsibilities or tools or what processes is inferior or anything like that. I'm just just presenting academically what are common things out there in industry. So yeah, this infographic is getting old, but it's a fascinating view into all the data that's generated out there. It's crazy. There's a PBS special, a few years old, about a DARPA, Defense Advanced Research Projects Agency drone that used an array of, I don't know, like 1,000 cell phone cameras, so really cheap cameras. And the amount of video data it collected every day was just staggering. And it would process the data. It could identify a human versus a dog walking across a park at a scale of an entire city in one view. Just spooky Big Brother stuff, but good example of the amount of data. We're working with Walmart on a data science program, and Walmart, if you look at, I don't know, it's like 11,000 stores. If you look at their peak intake, it's like 2.5 petabytes an hour of data from all sources, from store data, employees clocking in and clocking out, so point of sale data, social media data, supply chain data, where their trucks are, where that inventory is coming from distribution centers and all that. It's just staggering amount of data. And of course, the sexiest job of the 21st century, I think that came from IBM, is data science. And data analytics, a subfield of data science. So I see a lot of people that have data scientist in their job title, and they're analysts. But I'm telling you, you guys that get to work with data all day, every day, are in a growth career field. It's I think more interesting and a brighter outlook even than application developers, folks that they're actually making the websites and the mobile apps work. But I'm a data guy. That's where I got my start. So of course I'm going to feel that way. Yeah, a little bit about roles on a data analytics team. Do any of you work with a data scientist, a truly nerdy PhD level statistician that talks about machine learning and AI and all of that?
I don't.
Business analysts and software engineers.
Go ahead, Edgar.
I said I don't.
Okay. I heard another voice.
That's Dexter.
Dexter. Yeah, it's very faint.
Oh, okay. I'm sorry. Can you hear me?
That's
I work
better
with
now.
Yes, sir. I work with business analysts and software engineers, part of the integration team, cloud integration team.
Sure enough. Yeah, a true data scientist is like it's kind of like a biologist or a physicist or a scientist, in another category. They're pushing the envelope of what we know about data, what can be learned from the data. So these guys are kind of are responsible for, like, at the bank, Christopher, you've got fraud detection, right? Whenever a credit card transaction is committed, there are attributes about that transaction. Say it's, the store, the vendor ID, whoever took that credit card charge has a vendor ID. There's an amount, there's a location, there's a time since the last time you made a charge, there's a distance between the last vendor that you use that credit card at and the current vendor. So there's your own personal shopping habits, could have a code associated with it. So there's all these attributes associated with a transaction, and you feed that into, it's called supervised learning engine, and it decides fraud or not fraud based on all of these characteristics. And supervised machine learning is one of the things that data scientists have been working on like crazy in the last, I don't know, 15 years or so. But yeah, they're the guys actually expanding the methodology by which we do data analysis. And then you'll see machine learning engineer. Well, I don't want to skip one. Data engineers, Seth, are folks that are doing what Eric does up in the IT department. And data engineers, or data engineering, is moving data around from one source to another, and cleaning it, converting it to something useful, making sure that the layout of the data is correct, and that it's clean and pristine and ready for analysis or ready for use by whatever follow-on process. Could be an application, could be a data analyst, and then kind of putting it where it goes, where it belongs. So that's often something like a data warehouse, which I believe is what actually, believe it or not, my son and I don't talk shop all that much. But I believe that Postgres database is an attempt to pull data from a couple of different point of sale areas and make it look right and make it relational and lined up and get it into one place where it can be used. But I'm curious as we go through the course to see your take on that effort as well. And a machine learning engineer is the person that did I? Yeah, that looked like it was spelled wrong for a second. Engineer. Yeah, but a machine learning engineer takes those machine learning algorithms that have been developed and feeds data into them, makes sure that they're working, troubleshoots them if they break, because these things are living, operating software. They're a program running that takes data and spits out a result, so they have to be maintained. A data architect is really somebody that makes sure that all the data within a given functional area, or ideally an entire company, all the data is identified and there's a value placed against it. Where it is stored is designed appropriately. The processes that manipulate that data are mature. The audiences for that data are lined up so that you get your permissions right and everybody has access to what they need to, but doesn't have access to more than they need to. All of those things go into data architecture. Data governance would be another term you see being used with that. And then absolutely, business analysts are the folks that work with the customer, tease out the details, gather the requirements, make sure that you're getting to the root cause and the actual requirement of what they need to do, not how to do it. And domain experts are the people that they're working with. You need people that know the business domain to make sure that those requirements are going to be, keep the company competitive. And then of course you got software engineers, which are the folks coding up normally applications, but you're seeing more and more software engineers getting involved in analytical code, because just historically, your analysts and your data scientists are the worst coders, because they learn programming to a level where they can get it to work and they can get the answer that they need out of the code. And that goes back to programming in Fortran in the 70s. So they learn coding to solve a problem for themselves, kinda is, and I'm generalizing, but that's the phenomenon. But a software engineer knows how to develop code that works for everyone and can be understood by the next programmer that comes along, and uses the conventions that the company is comfortable with, that it's documented, it's efficiently written. It's not kind of just a hacked solution, although there you go. Like I said, I'm generalizing, but that's the idea. And it could be that you need to work with a software engineer within your company's software development requirements, ticketing thing, because maybe you're not getting the data that you need, or maybe the person that is doing the data engineering for you is also supporting application developers, and you've got to make your requirements known as an analyst, so that they can be folded in and prioritized along with other software requirements. It's getting to be that way, that these analytical products are software products, so you have to treat them that way, with configuration management and documentation and all that. Okay, any questions on roles, questions, clarifications of anything I said?
Question, Chris.
Go right ahead, Chris.
So if you had to put this kind of, or kind of sum things up from a practical perspective, kind of from start to finish, from when you get the problem to you have the final product, whether that's a report, chart, graph, whatever it is, how would you kind of organize these roles? Like for instance, the customer gives
Gotcha.
the business analyst, and then he passes on to this
Yeah.
person, and so on and so forth.
Gotcha. I got a slide on that coming up down here.
Didn't mean to jump ahead.
There you go. That orange looking slide. So if I don't address these roles as they map to these phases in the analytics lifecycle, slow me down.
Okay, sorry, I didn't mean to jump ahead.
No. Please. But man, guys, it's just us. Okay. The more the more interactive we are, the better this class will be. So please jump in. And it makes me feel good, Chris, that I have a slide to address that. So yay me. You're making me feel wanted. Okay, so this is interesting. This is an interesting graphic. That's I put it out there because I think it's funny and interesting and true. This is a Venn diagram. So you put a bunch of terminology out there, and then you draw circles around things that are in common to each other. If you haven't seen a Venn diagram in a while, so you've got four, like call it a knowledge domain here, four ovals: communication, stats, mathematics, programming skills, and then just pure business functional area. They know how the business works. And then these ovals show the intersection of these things, of these four attributes, and then it labels what that person is if if they have all of some of it and none of the other. You know what I mean? And like over here on the left, communication with nothing else. If you don't know anything about math, don't know how to program, don't know how the business operates, don't know anything, but man, you like to talk, hot air. I love that. And then the intersection, like if you look at the intersection of the communication bubble with the business oval down at the very bottom in the center, the salesperson. Yeah, they don't know anything about math or programming, but they can talk well and they know their customer and the business side. You got the salesperson. And then let's see this Drew Conway's data scientist. Drew Conway. I don't know where that came from. But like, somebody who knows how to program, but they don't know jack about anything else. They're the hacker. Somebody who knows statistics, but they can't communicate, don't know how the statistics are being applied. They're a data nerd. So, and anyway, yeah. And the what I think is interesting about this is they say analyst down here in the kind of the lower right corner, just a little bit, is the intersection of business, statistics, and communication. They don't include programmer, which I would have put programmer instead of statistics. I'd have put over where head of IT is instead of analyst. But anyway, I think it's an interesting diagram. I think if you Google the data scientist Venn diagram, if you're curious, you can go find the background of that. I forgot where I got it from. And then traits of a data scientist. This goes back into those guys that are expanding the technology, expanding the frontier of what we're doing. It's the intersection of math, software tools, programming. That could be SAP, SAS, R, Python, RapidMiner. So the technology that allows data science, particularly on big data sets, and then business acumen and strategy. There's a lot of folks that are nerdy, but they don't work well with customers. They can't express how a technique could be used to make the business more competitive or to lower costs, because they're so worried about the technology that they've lost sight of why. But you need these folks, but you need them to be balanced. So anyway, that's another diagram from datajobs.com that shows the and I think I think a lot of folks that are in an analysis position are borderline data scientists with just a little bit more skill in the more advanced tools. You guys would be working up to being data scientists, I would expect. So data analytics lifecycle. This is Chris, what you were talking about. So, and there are many models like this. I think I got my source down here. Yeah, vokesdigital.com. And you see so many of them. One is as good as the other, even though they might use slightly different terminology. But every data analytics project starts with a business problem, a question, something they want to know, a requirement. And this life cycle maps very closely to your typical application development, software development life cycle, because analytics products are software now. So your business analyst, from that slide number 5, your business analyst can be working with someone and tease out those requirements for analysis while they're working with that domain expert. And I've got a completely separate lecture here on business questions. What does that mean? But they need to be refined, just like a software requirement. The objective of a data analytics project is going to have an overarching requirement, like a top level requirement. Just like in software, we're going to build a customer service system. Well, you're going to need some more detail. You're going to need a lot more detail. And objectives for a data analytics project need to be, the onion needs to be peeled to come up with subordinate questions that feed up to that main question. How can we generate more customers? Well, that begs the question, how do we generate our customers? What is our customer base? And then you start, how do we segment these customers? Well, now in that segment, what drew that customer to our business or whatever? So there's a business analyst is good at that, or is supposed to be good at teasing out requirements that can then are sufficiently detailed that they can go into a design. So the way you design a data analysis product is you start with the data. So you've got these questions. These people want to know what was the best this, what was the worst that, what was the ratio of this to that. You go look at the data that you have and understand its format. You understand what you're capturing, how often, if you've got the right fidelity of the data, if it's in the right format, if the analysts have proper access. A lot of companies, they do a really good job of segmenting people's access to data. So an analyst kind of needs to be like a trusted expert that has access to stuff that your typical employee would not. So that's what just understanding the data, because little two bubbles later, you may need to work with your software folks or your IT department or whatever to enhance that data. But anyway, yeah, understanding data is looking at what you've got, and understanding is if you think you have the data that will address that question, at least in format. You may not have enough data. You may not have old enough data or recent enough data, but you've got the bones of it. But it may not be clean. It may not be in the right form. You may need Celsius instead of Fahrenheit, or whatever the case may be. And that's where data cleaning and data transformation comes in, which is kind of what, like at Bumper to Bumper, you've got 2 different point of sale systems out there in the stores. and they use like different part codes. Best as I can understand, they use different codes, and that's got to be transformed. It's got to be pulled out of those two systems, lined up, matched up, made sense of somehow, and then put somewhere where it can, it can be used. And that's the whole cleaning and transformation wrangling. You might have heard the term data wrangling. A lot of what you're doing in an analysis project is that, because there's so much dirty data out there, especially depending on the volume and the variety of the data that you're dealing with. Data enhancement would be where maybe you go back to the software folks and say, hey, our website is not collecting, beg your pardon, it's not collecting timestamp or something, or the IP address of the user or whatever. I don't, it's you're not getting something that you need out of your internal software. Or like, well, for example, we use a customer relationship management software called HubSpot, and we were not collecting enough data about the invoices for training. So we went in and added those fields to HubSpot and made everybody start using those fields. So that's data enhancement, is where you've got this business problem, but you don't have the data that you need, and you found that out in the understanding part. So you flesh it out, you enhance it. Data analytics that's where you decide, no kidding, what are the metrics or models, the measures that answer those business questions. We'll do a little bit on statistics, but it's, if they're asking for the biggest whatever, then that's the max, min. If they want to know the range of ages of people that are buying product X, there's a measure called range. So in data analytics is where you actually decide what measures, and you start sketching out what sort of charts would visualize that. Especially trends, people do really, really well with identifying whether a line is going up or down. Up is usually good, but not always. So, and then data visualizations, where you actually choose those charts, and start thinking of the data storytelling. You don't just create the chart and throw it out there. Sometimes you need to adjust colors to draw attention to things that the chart itself may not inherently do. Sometimes you need to throw a bumper sticker on there that says, this is bad or this is good, to make sure that you're actually highlighting data. You're not doing things that are misleading in the visualization. Like you'll see on the news, drives me nuts. On the news, they'll show like the Dow. Hey, nobody said, Don, you're talking yourself into oblivion. It's 17 after the hour. Is my lecture that captivating that you've also lost track of time?
No, we're just listening.
Okay. Well, let's break and I'll get back to this one. What time we got here? 17, 18 after? Yeah, 10:30. 10:30 to be continued.
Yes, sir.
Okay. Back to our fascinating discussion about the data analytics lifecycle. So yeah, back to the roles we were talking about, Chris. You're generally speaking, your data engineer is the person doing the cleaning and data transformation. Ideally, perfect world. You've got a documented list of prioritized requirements for analytics for that is answering what the C-suite folks want to know, or the board of directors or shareholders or whatever it is. And your data engineer is automating and troubleshooting and designing the ETL process, extract, transform, and load, that puts this data, and this is, ideally, into a data warehouse, which is a place where you can go and grab data off the shelf, just like you would a physical warehouse. That's why they use the term, right where the data is, how much of that data you have. It's documented. It's on shelf A3. It's a clean, pristine repository of information, because you don't want to be doing analysis off of the actual transaction systems. So generally people get a little nervous with that. So, and if the analyst yourself, if you're pulling CSVs and then doing analysis on dead data, it's not as optimal as an automated, refreshed process where the data warehouse gets new data at a frequency that responds to the information consumers needs. So that's where your data engineer comes in, with data cleaning and enhancement. Your analyst is the one that's deciding which analytics shed the most light on the situation. Data visualization, there's a whole lot of folks that are business intelligence developers. They're BI developers is what we got at least half a dozen in the apprenticeship program that are learning either Power BI or Tableau. I've got one at Rock Dental Brands that we paid for Tableau e-learning pass, which was like 5 instructor-led, basically week-long courses, plus a whole lot of self-paced stuff and office hours and whatnot. But just for Tableau, just for that data visualization part. So she works within a team. And that's when the magic happened. When a lot of places, it's just one person, you're doing your own everything. You're talking to somebody about what they need to know. You're finding out the data. You're going back to the software guys going, hey, we don't have this in the database. And, the same person is doing all of this. But the larger the company, the more you start to see a more formal working group. Well, Seth, are you back online?
Yeah, I'm here.
At Bumper to Bumper, do you have like you're in the marketing department, right? Really more looking at effectiveness campaigns and stuff.
Yes.
Do you have, say that's one functional area, marketing? Do you have people that are in the like the finance wing that are analysts that you kind of speak to, work with as far as requirements are concerned, or maybe somebody in the logistics department that's looking at all the the parts that are on order versus inventory levels or whatever?
I've only been here for about a month and a half, so I'm still learning like the organizational structure and everything.
Okay.
But it seems like we're downriver from that, as far as I know, right? Like, I believe you talked about like there's software engineers and stuff on the second floor who set things up for us, right? And then we have our own part of the database that we can access and look at for information, like, are these customers signed up? What are they signed up for? Who is somebody signed up for the wrong thing? We're kind of checking to make sure it's all right in that way. But other than that, I don't really have I haven't had a whole lot of contact with anybody else other than that.
Okay. Yeah, I only know for sure for certain one organization, and they have what they call a data analytics working group, the DOG. And the data analytics working group are it's not the business users necessarily. I think they do have a C-suite person that is their main advocate, but they work together to make sure that common concerns, common tools, for training, common access to data, common problems with the database that might overlap different functional areas are being addressed. So I don't know, it might be something worth looking into as you expand your role there at Bumper to Bumper. I know you just got a new CIO. He may be looking into things like that. Data analytics maturity model. This is from Gartner, which, who am I to argue with Gartner? This is kind of the continuum, the spectrum where folks are trying to get in the upper right-hand corner. But there's a whole lot of businesses that are still not really doing a very good job at the bottom left corner. But as you see, as the value of the maturity of your analytics goes from describing just routine reporting, what were sales last month, to getting more diagnostic as to why did sales go down last month? Well, predictive analytics. Well, what's going to happen next month if they went down last month? Oh my God, predictive analytics. And then prescriptive is where you're starting to kind of get into the magic. How can we make it happen? Well, that's the $64,000 question in a lot of industries, which there's a lot of. I would add another dimension to this. It gets harder as you go on the left-hand side from descriptive to prescriptive. It gets harder to do, harder to decide on the metrics, but the better you are at it, the more valuable that becomes. So I think there's another dimension, which would the amount of art involved versus science. I think there's an art to combining a bunch of different factors that you learned in descriptive and diagnostic analysis and then projecting that into the future, because there's a lot of stuff the data won't tell you that you might know in your own mind as a business leader. So anyway, that's what we're trying to do. We're trying to get from descriptive up to prescriptive. Most of what we're doing in this course is, of course, reporting, descriptive analytics. There's a lot of terminology. I'll hit this last slide. There's a lot of terminology that's overlapping and arguable as to exactly what it means and how it's implemented in practice. Like, what is data science? Data science is all of this stuff that has anything to do with utilizing data to inform decisions. You see the term big data. There's plenty of like YouTube videos and blog posts out there, but big data was, I think the phrase was coined in 2008. And it's an amount of data that generally surpasses a single server instance in size. So up into the gigabytes, and that keeps that threshold keeps moving as the software gets better. I think it was coined kind of before you had 64-bit operating systems. Anyway, there's 3 V's. There's volume, large volumes of data with great variety. So you've got structured data coming from relational databases. You've got unstructured data coming from documents and wikis and blog posts and social media analysis, semi-structured data in social media. You got video data that, if you could analyze that video data, it would tell you a whole lot about what's going on or what has just happened. So yeah, big data is all of those things, not just one of them. And it's not like you can just, throw a bunch of data into a big data repository and it just makes sense of it all. It's individual separate techniques. Like you might have heard of a database called Hadoop, That's the one of the first ones that was it was really more than a database. It was a file system, it's a distributed file system. So you could put different segments of your data that were in the same basic format on different servers, and then address the same task against each one of them, and it would happen in parallel. Like I've heard, when Google first, remember when you know how it does predictive typing, when you type in, you Google something, it searches in instantaneously across Google searches that have been typed in by other people and predicts what it is you want to know, because things trend. People are, everybody all of a sudden is Googling escape prisoner Alabama, and so it just, you type in ESC and it guesses that you're typing escape prisoner from Alabama, because that's what everybody else was typing that typed in ESC. And those sort of searches, they're done instantaneously because it as I was told, or as I read, it segmented them in a distributed computing environment. So yeah, big data, that's what it means. Lots of data coming at you really fast from a bunch of different sources. Like I said, 2.5 petabytes coming at Walmart every hour. So you got megabytes, gigabytes, terabytes, and then petabytes, and exabytes, or the other way around. Anyway, it's a lot of data. Data mining is where you go kind of plowing through the data looking for stuff that you're not asking a particular question. You're not going in doing analysis. There are algorithms. The ones I'm most familiar with are clustering algorithms, and they go in and look at attributes of the data, kind of like supervised machine learning, like we talked about a recommending engine or a fraud detection engine looks at different attributes of the data and decides good or bad, yes or no, fraud or not fraud, or it can be like a ranking, a scoring. But data mining looks at data and produces these diagrams, these that look kind of like a bubble chart, where it sort of highlights things that elements in the data have in common that you may or may not have even really realized. So it's like taking a tin pan out into the old west, and going to a river and dipping in some sand and swirling it around and going, oh, yahoo, found a nugget. It's literally looking through the data for nuggets of gold and maybe the data can tell you things that you didn't even realize without necessarily presupposing a particular research question or analytical question. So data mining. A data warehouse, again, is ideally a pristine central repository of transactional data that gets and you design this thing to fulfill a purpose. It's usually for analysis and reporting, but it can be used for an application can go pull data from the data warehouse, and it's clean and reliable. But generally speaking, it's a duplication of what's out there in your transaction systems, so that you pull it in, make sure you get things lined up, make sure you don't have blanks or duplicates or anything ugly like that. You give people access where it's appropriate, so you can segment your permissions. Business intelligence, again, is taking that analytical information and putting it into a product that's that is addressing the key performance indicators of the business, and they're usually interactive. Like on the dashboard of your car, you can reach down and change the channel. A lot of these dashboards, you can sort and filter and hide and whatnot, and the executive can now kind of tailor what information they're looking at in real time without goofing up like an Excel file. And if they make a change, they they've changed their version of the file. So that's BI. It's normally Tableau and Power BI from like an application standpoint. That's the desktop application market share, but there's getting to be BI in everything. Google's got a data studio in the cloud. You're seeing a lot of competition creep up out there. Like I said, one of the companies that's had a bunch of people go through this course use Domo, which is still very similar. It's kind of like an application on your desktop. So a lot of different terminology out there that's kind of, you just got to read it, get your own idea of your own understanding and how it fits in with where you work, and then use it for what it's worth. Cool. So Chris, did I cover what you were looking for in the roles and responsibilities?
You did. Thank you.
Say again?
I apologize. I'll say you did. I do appreciate it. Thank you.
Okay. It sounds like you might be on the forefront of putting that together too. So there you go. All right. So that's that one, man. I cannot, lucky for you, I cannot talk for 4 hours. Let's close that one out. But I did have another, and this is all just foundational stuff, guys. Hope it's worth your while. I wanted to talk about just tools of the trade real quick, and then business questions and problems, because I would like to give you some of your time back to start putting thoughts on paper, putting pen to paper for our very first exercise in the course, which is brainstorming your business questions. What is it that your analysis is trying to answer specifically? Okay, so tools of the trade. I'm not sharing yet, am I? Okay, and this one, I want to talk a little bit about personality traits, stats, and the software tools. This one won't take very long. So I have been an analyst. I think like an analyst. So I pulled this off the web. I didn't make this up. Some traits of a successful analyst are an inquisitive and quantitative mind. Quantitative meaning no kidding, numbers. What are the numbers behind that statement or that question? As opposed to, there's two fields of research broadly: quantitative and qualitative. Qualitative is more in the social sciences, where you're asking people, how they feel about things, and on a scale from 1 to 10, and you're combing through data to get their sentiment. In some ways, sentiment analysis off of social media is sort of qualitative, because it's looking for similar terms that mean the same thing, but then you roll that qualitative information into a quantitative measure of like what percentage of people are speaking negatively about our company versus speaking positively or whatever. So yeah, but inquisitive. When I watch the news, I almost have to bite my lip, because every once in a while my wife will get annoyed with me, because I'll pause it and say, now what's the data say behind that? They say, COVID, we had 10 times the number of deaths as Australia. Well, what's our population compared to Australia? They didn't say per capita. They just said the number of deaths. So there's an imprecision in the non-analyst's mind that drives me nuts. So yeah, generally speaking, love working with numbers, solving problems, and that kind of goes towards the whole, software developer mindset as well, I think. Another trait of a good data analyst is balance and avoiding researcher bias. Some people will go into a research project and try and find data that fits what they thought it was going to do. And that's not a good thing for an analyst to do. That's hedging the data, fudging the numbers. That'll get you into ethical issues in some companies. So the data is what the data is. You ask the question and the data answers, and the data is what the data is. Now, if it's odd and completely counterintuitive, maybe you go, looking for dirty data or missing data or whatever the case may be. But yeah, intellectual balance and try to avoid researcher bias. I think you have to be really persistent, particularly with the Googling and getting code to work, or getting a visualization to work in Power BI or whatever the case may be. Yeah, you really got to keep at it, and sometimes you walk away from it, go back to it, but it really helps to have a stick to itness. And I have found that you can be a good analyst, but if you can't communicate your findings in terms that make it interesting and actionable and important to your audience, it's kind of lost. You can't just throw a chart up there and look at the audience and think, duh, don't you get this? You you kind of have to be a decent storyteller to make sure that they get the so what. And again, want to avoid bias as you tell that story. But there you go, communication. So what are you guys seeing as good traits and folks that, of your own traits that you have that have come in handy, or of people that you're working with? What do you think, Chris?
I would add just having a love of technology, since data analytics is going to be technology driven.
So yeah, so a love of technology, which infers a love of learning, right? I mean, as quickly as this stuff changes. What do you think, Kevin? Kevin?
Yes.
What do you think?
I'm sorry. I had to step out for a second to let my dog out. Could you repeat the question?
Yeah, it's on the screen. We were just talking about the traits of a data analyst.
Honestly, I think the only thing that's not listed would be curiosity, which I guess inquisitive would be kind of similar. But with the people I work with or work around who love to analyze data, they're always like asking questions about it, at least internally, and trying to find patterns themselves. Like, what can I find that isn't presently obvious in the data? And I feel like since I just started recently, I think that's really been what has helped me learn, is trying to emulate what they do, is looking through that data, not necessarily seeing what is there, but what could be found. If that makes sense.
Sure. Yeah. I would be curious what a data mining effort might show. That's usually the tool that we talk about that finds previously unknown relationships in the data. I'll try and get. I've got a colleague at University of Central Arkansas that does a good talk on cluster analysis and what it can, the kind of things it can do. I'll see if maybe I can get him give us a talk before we conclude in August. So, yeah, good points. Your knowledge of statistics. I like I said, collection and organization and interpretation of data. There are, PhDs in statistics. I got a buddy that calls it statistics, mostly for the second. If you've had Stats 101, you had to come up with p values and confidence intervals and all that. If you've never had Stats 101, a lot of the terminology can be confusing. I haven't had stats since I was an undergrad in the mid 90s. I did have a quantitative methods when I was getting my doctorate, which kind of reattacked some of the notion. But yeah, basically you've got, descriptive, which can summarize the data as it sits, either looking at like one column of data. Maybe it's the age of respondents of a survey. So you've got the age going, 45, 53, 37. You can describe that data. You can find the mean, the minimum, the maximum, the range, the standard deviation, all that. I got a quick refresher on all of that stuff, but you can't infer the mean of that data set to the larger population of whatever, of a country or a county or a company. And that inference from a sample to, which is just, a select small subgroup of a population. So you take a sample, maybe 100 people, you ask 100 people, what's their favorite ice cream? Depending on the sample size compared to the population, you can infer, well, if 50% of my sample like vanilla, then 50, within a certain confidence interval, I can say that 50% of all of America likes vanilla. But there's all kinds of factors involved. There's sampling bias. If you can't go to, Seattle, Washington, and ask what their favorite flavor is and expect that sample is going to have inferential value in, I don't know, Miami, Florida. It's too focused of a sample. It's not random enough. So there's all kinds of stuff that, as far as inferential. Are any of you guys using inferential statistics at work? So there's no, we looked at 100 of our customers and this was what the data said about them. We're going to extrapolate from those 100 customers what the 2 million customers feel or do, or what the likelihood would be that they would act the same. Okay.
Not at Shiloh.
Edgar, go ahead.
I said not at Shiloh.
There you go. And that's what I have found. Because most of the analysts that go through this course are in a business that is reporting on actual data that they have and making decisions based on that data. I haven't had anybody that's working for like a polling company or doing, experimental design. So there you go. Well, I still think it's interesting to know. I think it's interesting to know as an analyst, as a tech person, and as a citizen. It's interesting to know how that works, how that technique works. There are laws of probability, and there's a few dynamics that go into that. But if you've never had stats, I hate to. Have you all had statistics?
I have. I've done up
Yes.
through
Seth, you first. What's your stats background?
Sorry. Yeah, I never took statistics. I took calculus as far as you could go, but I focused more on that side than like business math or statistics in school.
Cool. Well, Seth, the whole probability of, you know, of the way they do the sampling error is they use calculus to define like the area under the normal curve. So you do like the derivative or whatever, the integral, and the chances of something showing up within the area of that curve is how they do. So you had to have a little bit of calculus, or at least a little bit of knowledge of it back in Stats 101. Edgar, you were going to say something?
I have statistics in college. It's probably just the first statistics 101.
There you go. That's what I had. How about you, Chris?
Same, statistics in undergrad,
Do you remember it?
bits and pieces, need a refresher.
So if I asked you to calculate the p-value of a sample of 112 survey respondents, that would take you some Googling.
Right.
Me too. Like I said, I do not use it. But it's like I said, I think it's good to see. And then, you know, if you've never had stats, or if you need a refresher, or if your work wants to start inferring, it may be that you take a refresher course. But that really is what a data scientist is good at, is designing an experiment and then collecting the data and then going, okay, we've got a 95%, we're 95% confident that this would extrapolate to the broader population and that it didn't occur by chance. And it's statistically significant. Okay, moving along. Next one is Excel, good old Excel. I think everybody uses it to some level. We will make sure in this course that we will go over basically all the chart types that you can do in Excel, because that is the same set that you can do in Power BI. There are some advanced visualizations out there for particular types of data that we may or may not get to. But if you guys at where you work are using a particular type of visualization that we don't cover very well, I don't know, a heat map versus a pie chart or whatever. If there's some visualization that you guys are using, please, you know, contribute that to the discussion. But we'll make sure that you know all the, you know, the keyboard shortcuts and formulas and what Excel can do as a tool for an individual data analyst. I don't even, there's a lot of stuff you can do in Excel to turn it into like a data entry application where people are actually typing in data and hitting save, and it goes and it writes it out to another sheet. And people are doing literally, you know, monthly reports with Excel. Well, that's what I want to move towards, that reporting and that storytelling. I want to move towards, you know, Python, Jupyter Notebook, and Power BI. But that's what we'll cover with Excel, and it is still remains what, almost 40 years later. And there was Lotus 1-2-3 was even before Excel, a powerful, valuable tool for combing through data. So like I said, individual data analyst, not necessarily reporting. But yeah, what's that, a million rows, 16,000 columns. I can't imagine why or how you would ever need 16,000 columns, but it can handle it. So what, a million times 16, 17 billion rows, cells, just enormous. But, you know, a million rows, you start to see that exceeded. And like I'm dabbling in BigQuery on Google Cloud Platform, and it's something you could throw a CSV with, you know, 3, 4, 5 million rows up to it, and it will operate. But it's not a spreadsheet. It's more like a relational database. It's this SQL based tool. So there you go. SQL, or I mean, I'm sorry, Excel. Some folks, it's like a prereq. You know what I mean? Well, I got to know Excel, including VLOOKUP. So, like I said, I'm deciding. I'm finding out which week Mary Kate's going to come in and cover Excel, but she knows she knows VLOOKUP intuitively, and she'll make sure we can all do it. But yeah, VLOOKUP is where you've got like two worksheets. One of them is like a lookup table, and you can go find a value in another table or another sheet and translate something out of that worksheet into your worksheet, like a table join in SQL. So maybe I don't use it because if I was ever going to do that, I would have queried it out of the database where I didn't have to do it in a spreadsheet. But some folks are more comfortable with a certain tool, and there's there's more than one way to skin a cat, however you want to say that without being anti-animal. There's multiple solutions to any given problem. And what you do, you folks that have SQL access to a database, what you do in SQL versus what you do in Excel, once you've queried that data out into a flat file, kind of depends on your comfort level with those tools. It could be that somebody who's better at SQL than you could eliminate a step that you're doing every time in Excel because they know how to figure it out better in SQL. I wrote a Python program that goes through a CSV looking for unpaid invoices because I think like a programmer. I think like an iterative, for loop, chunk through the data. That's the way my brain works. So it was quicker for me to do that in Python than I would have been able to do it in Excel. I think it would have been kind of manual in Excel. I might have been able to write a macro, but I don't want to learn Excel macro language. So it all depends on what tool. So here's another tool that we'll learn: structured query language. It was an established language when I got into IT in 1988. So this is one of the technologies, perhaps the only one, that was around and being used and useful 34 years ago when I got into IT, that is still around today, still useful, still required. Relational databases, will not go away until we get, I don't know, HAL 9000. You just have a artificially intelligent Skynet computer that knows everything. This is a very mature skill. Now we will use SQL for querying, for getting data, and for answering business questions, like a brain teaser. Which salesman sold the most widgets with the largest profit margin, or whatever. We'll do some brain teaser querying to make sure that you're, to give you some practice with where clauses. Some of you will breeze through this stuff no problem. It might be fun and challenging for others, but we'll mainly be using SQL for what the Q stands for, query language. But generally speaking, within all databases, like computer science database theory, there are these different languages or different functionality that a language has to have. And this can be in, MongoDB has a different DDL and DML and Mongo query language. Node4j has a different query syntax and a different data manipulation language than SQL, which you see in all the, Postgres, Oracle, MySQL, SQL Server. But it can also be a data definition language. I'm just throwing these out as fun facts. Data definition language is how you create your tables and views and columns and whatnot. Data manipulation language are like inserts, updates, and deletes of the data itself. Data control language, I believe, is where you will add permissions to grant grant privileges on a table to a user. Transaction control language is like commit and rollback, where you can make a change to the data in the database, but then you can say oops, and you can roll back that and not commit it. But like I said, we're not if you're a no kidding data engineer, you're using all this stuff, creating temporary tables within your script that only live while you're doing your extract, transform, and load. And then when you're done with it, you delete it, and you're inserting and updating and using all the full functionality of SQL. But we're just going to be working on SQL queries. And then good old Python, my favorite thing in the whole world. I started out with a language that I doubt any of you have ever used. Pascal was the teaching language when I came up, and it died a natural death. Got taken over by like Visual Basic and C and C++. But Python to me is the new Pascal. It's what the kids are learning, if then else, in 4th grade now. So it is a general purpose programming language. It is perhaps the best Swiss Army knife programming language out there today. It, like everything else, it's open. It's open source. First released in '90, but it wasn't until maybe the last 10 years that it really got going. It is object oriented, like for those of you who've had some object-oriented programming, like you don't use a substring function. You don't pass a string variable to a substring function and say, give me from character 3 to character 5, as parameters. There's a particular part of the language that's built into it. There are a lot of methods, class methods to work with stuff, to work with variables instead of functions. And it's just kind of weird when and I'll still get confused. It's not like I work with Python every day. I use it for teaching, and a little bit of my own hacking around. But sometimes when you're expecting there to be a function, it's not a function, it's a method of that class. So you just got to kind of understand how that works. You can create classes in Python, but we won't go quite that far. We'll be doing all of the usual, elementary computer science constructs and data types, and then we'll move into data analysis with it. But you got to know the basics, or if you jump right into the libraries that do data analysis, I think you'll find that you struggle with the basic syntax. So we'll go through it all just to make sure everybody's up to snuff. And the strength of the libraries, it's open source and people are extending the functionality of it in a community of developers, unlike anything I've ever seen. And one of the main libraries that lets you monkey around with data kind of like a spreadsheet is called Pandas. And we'll play with Pandas probably more than you want to. But like I said, this lets you script the easy stuff. This lets you automate with the, once you figure out what it is you're doing with this CSV you get every month, you can automate all of that data wrangling and transformation and whatnot. And it can, draw your first set of charts or whatever. So people use it for exploratory data analysis in Jupyter Notebook, but the real power to me is your ability to automate the boring stuff. But we will, spend plenty of time with Python. And here's a couple years old, shows the rise of Python in familiarity and by number of searches on Stack Overflow, which is like Not my favorite tutorial, but a lot of times it's you got to go there to get the answer. It's a social media site for developers to ask and answer questions. So there is your beast. And R, not even mentioned on this slide, but R is just kind of turning into like a nerd only tool. It's very much like Python in its data analysis capability, but I don't know that there's anything you can do in R that you can't do in Python. Some things are in the main language. We're going over time here, but I'm gonna wrap it up after this presentation. We'll pick it up on Thursday. Is the real choice of a of real data scientists. If you go to a computer science department at, like, University of Arkansas or University of Central Arkansas, and they do a statistics course, you're probably going to use R. It's slowly converting to Python, in my experience, in my observation, but they're still using R. The choice of real data scientists and pirates, R. Get it? Everybody get it? Pirates are. Do you know why pirates are so angry?
Why?
They just are. I know, right? It's time to part ways for the day. Okay. Yeah, that's R. We won't touch it. If you want to learn it, because your company loves it, there's tons of tutorials out there that are just fantastic. And then we got, of course, visualization tools, Power BI. It's the final step. Generally, you come up with all your measures and then you design your visualization so that it follows all of Gestalt principles and Tufts principles, and everything's lined up and the eye goes where you want it, and your colors are allow you to separate the data, and you're using the right amount of different shapes in your visualizations versus different colors and whatnot. Power BI, Tableau. I need to take SAP off of that. I think that's really more of a ERP. SAS, I think, is what I really meant. Google Data Studio. We had quite a few people using that last course. A lot of people are going to Google Data Studio and getting off of applications installed on a computer, because you can work from any computer once you got it in the cloud. So I've read that Tableau's the market leader, but I think if you combined all of the other ones together, Tableau's not that dominant. But especially in Arkansas, a lot of Microsoft shops, and they like Power BI. But you can do visualization in Excel. Python will allow you to draw any graph you want, and it's not nearly as intuitive as a WYSIWYG graphical user interface tool like Excel or Power BI. But you can adjust the font size of the X index numbers and the colors in the charts. Whatnot. We'll get you up to familiarity with Matplotlib and Seaborn libraries. But you can do visualization in those, but the basic rules come back as far as making things not too crowded with information, making sure the colors make sense, but you're using an accessible color palette. 10% of the men on the planet are colorblind. So there's some rules that we'll go over and whatnot. So which tool is best? Whichever one you want to use, whichever one you're most comfortable with, or that your company says is best. Sometimes you got to kind of standardize for the sake of repeatability and training and investment and resources. You have to standardize. So you guys use whichever tool makes the most sense to you and your team. Okay, and then Yeah, do it. Are any of you working on let me pull up the screen here. Are you doing analysis within a system? I'll give you an example. When I was at UCA, we had Salesforce that would do some reporting for you. So you didn't have to that, but that's where your data was. But it also included some ability to do charts and graphs within that software system itself. Are any of you guys doing analysis with a system's built-in capabilities like that? Or is everything external? Seth, I'll pick on you.
Well, what I've been dealing with hasn't really been anything for like charts and graphs. It's been more like pulling data into like a Microsoft Access database that then builds a report there that we use to determine like how much of these customers earn back through our promotional programs, and then we email that out to them as like a report from Access.
Who's the them?
Them would be like customer, like we sell parts to stores who then sell parts to customers, right?
Okay.
It's basically how it works here. So those customers, like the end customers, can earn back a certain amount of money depending on the part code of parts that they purchased, right? So we send a report to the store, which then will tell the customer, like, hey, over the quarter you earned this much earn back from your purchases.
Okay. And the inventory system or the point of sale system does not provide that. You have to pull the data out and use Access to determine that.
Yes, basically. Gotcha. Like we have the database of all their like transactions and everything, and then we take that data ourselves into Access and like manipulate it so that we get the numbers that we need.
Gotcha. Okay. How about you, Kevin?
Sorry. From what I've done so far, we mainly dealt with the Intellect platform. So our clients will enter data there, and they mainly just use that for their analysis purposes. Sometimes we'll make reports to aggregate the data in a more readable format. Occasionally, we'll use Excel to make their data prettier when they give it to us if it's not in the correct format for us to put in. But that's about the extent of what I've dealt with so far. I know in the past, Marius and Don, I don't know if you know Marius, but they have used like Power BI for other purposes as well.
Okay, and that's Intellex is what that's environmental.
Intellex, yeah.
Intellex, yeah, environmental. What do they call it? An episode or what's that platform? What's that? It's a software as a service. It's something that.
Yes. It's for tracking like ESG and stuff like that. Is that what you're referring to?
Yeah, for tracking what?
ESG indicators, like environmental, social, and governance.
Okay. Yeah, I'm gonna have to Google that again. I learned what Intellex did a year ago when I got Don and one other person into basic Intellex training.
Yeah.
A long time ago. But anyway, it's software as a service, but it does its own reporting. In fact, that's kind of what it's good for, right? It is a reporting tool, is it not?
Yes.
Yeah. Okay. There you go. How about you, Chris?
Mostly external. We query our data from our core processor and then take it and dump it into Excel spreadsheets. And we're doing a little bit more with Power BI, but that's going to be the direction. We'll use that as our business intelligence software going forward.
There you go. Okay. Well, guys, I'm a brain and mouth. I'm talked out. What I'd like to do is give you back the last hour. And I mean, you don't have to do it in the next hour, but like I said, I try not to capitalize more than 8 hours of your time pursuant to our agreement with your employer. But I want you to take a look at the assignment in Canvas. Let me stop sharing what I'm sharing and share my whole screen and go into Canvas. Let me bring it up. Canvas dashboard. Access denied. There it is. And in the foundations module, there's a business analytics problems assignment. Pull that up, just click on that link, and then I put the instructions in here. I'd like between today and I'll likely give you another hour on Thursday. I'd like for you to write a fairly thorough, I mean, I'm giving you back probably 2 hours, you know, a fairly thorough inventory of business questions. And like I said, there's in Canvas, if you want to preview it, there's a business questions PowerPoint that goes into a little bit more about what a business question is, if that would be helpful. And then like the data landscape, you know, we've got this information in Intellects or the banking software, and we have to pull it out and transform, you know. So there are questions, you know, I would like for you guys to write up, and I would expect, you know, the number one, it to be I would expect it to be hierarchical, like top level questions, and then what are the underlying detailed questions that feed back up to that one. But I would expect for there to be a lot. I've had, you know, students in the past before that they take this time and they just go back to work. And they don't, you know, and then I have a conversation with their boss and they're like, no, what? Oh, we've got all kinds of questions, you know. So take this time and look at these three questions. And between now and, like I said, an hour Thursday, start putting pen to paper, and you'll turn that in response to this assignment. So that lays the foundation for everything we will be doing going forward, and it gives me a context. It helps, you know, if you haven't done it before, it gives you a chance to get with your mentor or supervisor and start putting these on paper, and start, you know, thinking about how you would address them, prioritizing them, and then moving forward towards our final project. Very often, your final project will be something along the lines of what's being asked here. Okay, so before we adjourn, I did want to say, Dexter, if you want to get together, Dexter, correct me if I'm wrong, but you do more diagnostic analysis on data runs than you do like a typical, you know, sales report kind of thing, right?
Yes, sir. But we do reports, but it's more of like the analytics is more of like runtime, the disparity of between jobs. It's a lot of jobs.
Right.
It's something
Excellent.
I've never seen before. So.
No, that's great. I was hoping.
Cloud-based.
Okay. I was hoping that you were doing some reporting on those errors and runtimes and whatnot. So yeah, no problem. So this may be, your client may not be asking you, your client may not be asking you for new information. I don't want to assume that your scenario fits as well as maybe somebody else's does. So if you want to get together offline and talk about how to address some of these questions. Some of it'll just be about the tool, and it's just a useful way to, learning how to use Power BI or Python or whatever, and that'll be fine. But if some of these assignments, especially preliminarily like this, or maybe the capstone, if they don't exactly fit into what you're doing, and this goes for all of you, not just Dexter, contact me so that we can hash that out. Okay.
Yes, sir.
All right, cool. Okay. I'll see everybody back. Any going once? Other questions, concerns? Twice? All right. I will see everybody back here Thursday morning at 8:30. Have a good one.
You too.
All right. You too. Have a good day.